हेलो स्टूडेंट। आज लेक्चर को समस्त को स्वागत। बेसिकली आज लेक्चर रे आमे हाइपरबोलिक फंक्शन लो नेक्स्ट सेक्शन जोडा रहिला हमर प्रॉपर्टीज ऑफ 10 हाइपरबोलिक फंक्शन विषय हम स्टडी करिवा। ठीक अछि, ये हो हमर लेक्चर नंबर 5। या पूर्व हमें चारटा लेक्चर ऑलरेडी हम चैनल अपलोड करि सरिछु। किछटा लेक्चर लाइव रे अछि, किछटा लेक्चर अपलोड हेछि, तमे समस्त जाई के आराम से देखि परिबो। ठीक अछि, चैनल मेन पेज को विजिट करिके प्लेलिस्ट सेक्शन को जाई कि मध्य त माने हाइपरबोलिक फंक्शन जो प्लेलिस्ट थिबो तो सेठु तमे विजिट करके सब लेक्चर को सिक्वेंशियली पढ़ी परिबो। ठीक अछि, ओके। तो देरी न करी आज लेक्चर को स्टार्ट करिवा। बेसिकली फास्ट हमें देखि दबा प्रीवियस लेक्चर रे कोन पढिचंती। ठीक अछि, देखो प्रीवियस लेक्चर रे हमें cos हाइपरबोलिक x रो प्रॉपर्टीज सब डिस्कशन करथिले। ठीक अछि, cos हाइपरबोलिक x रो प्रॉपर्टीज डिस्कशन करथिले। जेमिति का देखो डेफिनेशन बा तार फार्मूला कोन दिला, cos हाइपरबोलिक x इज इक्वल टू e टू द पावर x प्लस e टू द पावर माइनस x बाय 2। ठीक अछि, देखो एटी जो cos हाइपरबोलिक x अछि हमें कॉम्बिनेशन ऑफ एक्सपोनेंशियल फंक्शन। ठीक अछि, कॉम्बिनेशन ऑफ एक्सपोनेंशियल फंक्शन रे हमें एक्सप्रेस करछन। ठीक अछि, cos हाइपरबोलिक x इज एक्सप्रेस्ड एज द कॉम्बिनेशन ऑफ एक्सपोनेंशियल फंक्शन e टू द पावर x एंड e टू द पावर माइनस x। ओके, hence the domain of cos hyperbolic x is equal to r. Okay, and what is the range? Basically range of cos hyperbolic x is equal to 1 to infinity, and 1 is included. Okay, basically what is the minimum value of cos hyperbolic x? Basically the minimum value of cos hyperbolic x is equal to 1 at x is equal to 0। ठीक अछि, जेतेबेले x 0 हबो सेतेबेले cos hyperbolic x तार minimum value दबो। ठीक अछि, ओके। ये सब हमें प्रीवियस लेक्चर रे पढिथिले। ठीक अछि, एबे देखो तो at x tends to infinity cos hyperbolic x is equal to infinity। Also limit x tends to minus infinity cos hyperbolic x is also tends to infinity। Okay, and the derivative of cos hyperbolic x is equal to sin hyperbolic x, and cos hyperbolic x is decreasing on the interval minus infinity to 0 and increasing on the interval 0 to infinity। And what is the graph of cos hyperbolic x? This is look like this। Okay, here is the point 0 and 1। Okay, ये सब हमें प्रीवियस लेक्चर रे पढ़िथिले। जो माने प्रीवियस लेक्चर देखिनो तो से माने प्रीवियस लेक्चर को फास्ट देखि दियो, तापर एटा को देखो। ओके, नेक्स्ट दिबा देखिबा 10 हाइपरबोलिक x विषय में स्टडी करियो। ठीक अछि, जेमिति कि हमें ट्रिगोनोमेट्री रे पढ़िथिले tan थीटा दिस इज इक्वल टू sin थीटा डिवाइडेड बाय cos थीटा। सिमिलरली tan हाइपरबोलिक x इज इक्वल टू sin हाइपरबोलिक x डिवाइडेड बाय cos हाइपरबोलिक x। ओके, तो sin हाइपरबोलिक x रो फार्मूला कोन थिला, e टू द पावर x माइनस e टू द पावर माइनस x डिवाइडेड बाय 2 डिवाइडेड बाय cos hyperbolic x ର ଫର୍ମୁଲା କଣ ଥିଲା, e to the power x plus e to the power minus x divided by 2। ଉପରେ 2 ତଳେ 2 କୁ ଯଦି ଆମେ କ୍ୟାନସଲ କରିଦବା ତାହେଲେ ଏଠି କଣ ରହିଯିବ, e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x। ठीक ଅଛି, so the formula of tan hyperbolic x is equal to e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x। Okay, the hyperbolic tangent is similar to the ordinary tangent function, but based on the exponential function rather than the circular function। Okay, बेसिकली आमे जेतेबेले tan थीटा को डिस्क्राइब करथिले बा डिराइव करथिले तार फार्मूला को, सेठी आमे सर्कुलर फंक्शन और ट्रिगोनोमेट्री रो फार्मूला सब यूज करा होतला। ठीक अछि, सर्कुलर फंक्शन कोन देखा आमे एठी गोटे यूनिट सर्कल को नेकी सेठी आमे राइट एंगल ट्रायंगल को नेकी ए सब जिंस को डिराइव करथिले। ठीक अछि, बेसिकली एठी जेतेले आमे हाइपरबोलिक फंक्शन विषय स्टडी करछंती एठी सब आमे हाइपरबोला यूज करिवो। ठीक अछि, it represents the ratio of hyperbolic sine and hyperbolic cosine and is commonly used in calculus physics and engineering। ये तीनटा ब्रांच रे हम एठी commonly यूज करंती। ठीक अछि, and one of the basic properties or main properties of tan hyperbolic x is tan hyperbolic x is an odd function, and so tan hyperbolic minus x is equal to minus time tan hyperbolic x। तो एठी तमे देखि परिबो, देखो हमको जदि प्रूव करिया ପାଇଁ ଅଛି tan hyperbolic x is in odd function, how to show? Basically take tan hyperbolic minus x and show that this is equal to minus time tan hyperbolic x। First we have to start at tan hyperbolic minus x is equal to, we can write as sin hyperbolic minus x divided by cos hyperbolic minus x। Okay, Since the sine hyperbolic minus x is equal to minus times sine hyperbolic x divided by cos hyperbolic minus x is equal to cos hyperbolic x. Since cos hyperbolic x is an even function, so cos hyperbolic minus x is equal to cos hyperbolic x. This implies into minus 1 into sine hyperbolic x divided by cos hyperbolic x. This is equal to 10 hyperbolic x. So we show that 10 hyperbolic minus x is equal to minus times 10 hyperbolic x. That implies it is an odd function. Okay. Next, ଯିବା ବର୍ତ୍ତମାନ ଦେଖ domain of 10 hyperbolic x. What is the domain of 10 hyperbolic x? Basically, 10 hyperbolic x is equal to e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. This is the formula or definition of 10 hyperbolic x. Okay. Here, the denominator is never zero for any value of x. Okay. Because e to the power x plus e to the power minus x, if we start with contradiction, let e to the power x plus e to the power minus x is equal to 0. Then e to the power x plus, we can write e to the power minus x like 1 by e to the power x. This is equal to 0. Now, e to the power, let's take the LCM, e to the power x, and e to the power x into e to the power x is equal to e to the power 2x plus 1 is equal to 0. Now, e to the power 2x plus 1 is equal to 0 into e to the power x, that is equal to 0, and e to the power 2x is equal to minus 1. This is a contradiction because e to the power x never 0 for all value of x. Okay, because e to the power x is greater than 0 for all x belongs to R. For all x belongs to R, e to the power x is positive, and the range of e to the power x basically uh, 0 to infinity. Since e to the power 2x never 0, so e to the power x plus e to the power minus x not equal to 0 for all value of x. The denominator cannot be 0. So 10 hyperbolic x is defined for all value of x and for all real value of x. Okay. Because e to the power x and e to the power minus x is defined for all value of x, which x belongs to R. Okay. So the domain of 10 hyperbolic x is equal to R. Okay. Next, uh, move to range of 10 hyperbolic x. Now, basically, ଯେତେବେଳେ ଆମେ x tends to infinity ଆଉ x tends to minus infinity ରେ behavior study କରୁଛନ୍ତି, basically ସେଟା ହଉଛି asymptotic behavior. Okay. ତ basically next ଆମେ ଯେତେବେଳେ hyperbolic function ପରେ curve tracing ପଢିବା, curve tracing ରେ ଏସବୁ ଜିନିଷ ଅଛି, asymptotic behavior କଣ ଏସବୁ ବିଷୟରେ ଆମେ ସେଠି discussion କରିବା, ଠିକ ଅଛି? ତ limit x tends to infinity 10 hyperbolic x, that means e to the power x plus e to the power minus x divided by e to the power x अच्छा sorry ଏଠି ଆସିବ minus, ଠିକ ଅଛି? e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. What is the value of this expression? Basically, we can write this expression as limit x tends to infinity e to the power x minus 1 by e to the power x all divided by e to the power x plus 1 by e to the power x. Okay, now let's take the LCM. This is equal to e to the power 2x minus 1 divided by e to the power x divided by e to the power 2x plus 1 divided by e to the power x. And let's take the limit x tends to infinity. Now cancel e to the power x and e to the power x because e to the power x not equal to 0. Hence we can shell e to the power x from numerator and denominator. Okay, now limit x tends to infinity e to the power 2x minus 1 divided by e to the power 2x plus 1. Basically, this is in the form infinity by infinity. Here we can apply L'Hospital rule. Okay, L'Hospital rule we can use here. Okay, now as the derivative, we can get e to the power 2x. The derivative of e to the power 2x is equal to 2 times e to the power 2x, and the derivative of minus 1 is equal to 0. So, plus 0. Okay, get it. Okay. Now, the derivative of e to the power 2x is equal to 2 times e to the power 2x, and derivative of 1 is equal to 0. Okay, let's take the limit as x tends to infinity. Now, cancel 2 and 2 from numerator and denominator both. Okay, now here e to the power 2x not equal to 0 and e to the power 2x not equal to 0. So, we can cancel it. So, we get 1. So the limit extends to infinity, tan hyperbolic x is equal to 1 or tends to 1. Alright, okay. When x tends to infinity, the tan hyperbolic x is approaches to 1, not equal to 1. So basically, tan hyperbolic x, ଏଠି ଆମେ x ଜାଗାରେ infinity use କରିପାରିବାନି. Here you cannot use infinity directly here, but when x tends to infinity, the tan hyperbolic x tends to 1 or approaches to 1, but not exact 1 at infinity. Tan hyperbolic x not exactly equal to 1. Okay. Now, similarly, we can find the limit x tends to minus infinity, tan hyperbolic x is equal to minus 1. So, it is a try karo. This is your homework. Try to solve look like this. Okay. As x tends to plus or minus infinity, the exponential terms dominated, making the value of tan hyperbolic x approaches to 1 or minus 1. However, it is uh, never actually reaches this value. Hence, the range is of an interval minus 1 and 1. Okay. What is the meaning of never actually reaches this value? If we take e to the power x plus e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. If we take this is equal to 1, then we can get a contradiction. Okay, e to the power x, we can write this like to the power x minus 1 by e to the power x divided by e to the power x plus 1 by e to the power x. This is equal to 1. Then here we can get e to the power 2x minus 1 divided by e to the power 2x plus 1, which is equal to 1. Implies e to the power 2x minus 1 is equal to e to the power 2x plus 1. Here we can cancel e to the power 2x from both sides. Here we get minus 1 is equal to 1, which is in contradiction. So the value of tan hyperbolic x never 1 and similarly never minus 1. So the range of tan hyperbolic x is equal to the often interval minus 1, 1. Now the graph of tan hyperbolic x is like this. Okay, here is y is equal to 1 and here is y is equal to minus 1 and the graph is bounded by these two lines. Okay, so the maximum value of tan hyperbolic x is basically 1. Maximum value of tan hyperbolic x is equal to 1 and the minimum value of tan hyperbolic x is equal to minus 1. Okay, no, এটা হবো না, এটা maximum নয়, এটা upper bound হবো. Okay, basically 1 and minus 1 is not belongs to the range set. So the supremum of range set of range set of tan hyperbolic x is equal to 1, not maximum, the range is because the range is of an interval 1 and minus 1. So 1 cannot be the maximum value. 1 is upper bound and minus 1 is the lower bound. Okay, not maximum. Here is the infimum of range set is minus 1. Okay. The curve approaches asymptotes y is equal to plus 1 and minus 1 but never touches them. The function is S-shaped and symmetric about origin. This is a continuous function which is bounded by y is equal to 1 and y is equal to minus 1. Okay. Now here is a question. What is the value of limit x tends to infinity tan hyperbolic x? Already we have discussed. This is infinity and sorry, this is 1 and this is minus 1. Okay. What is the value of tan hyperbolic 0? This is basically 0 and you try to find this value. This is your homework. Okay. Okay. Now monotonicity behavior of tan hyperbolic x. Basically, tan hyperbolic x is equal to sine hyperbolic x divided by cos hyperbolic x. And the derivative of tan hyperbolic x is equal to sec hyperbolic x, which is always positive for all value of x. So, tan hyperbolic x is always increasing function. And this is strictly increasing function. Look the graph. Basically, here the graph is in increasing mode. Okay. Now, 1 and undo ratio of tan hyperbolic x. Basically, if there is a theorem, if a continuous function and if the function is strictly increasing, that implies this is 1 function. This is a 1 function. Or we can test this function by horizontal line test. The graph of the function is looks like this. By horizontal test, what is the meaning of horizontal test? Basically, if we draw horizontal line, if the horizontal line intersect the graph at the most once, then we can imply that the function is one function. By horizontal line test, we can conclude that tan hyperbolic x is a one function. Okay. Now, what about the untoness of tan hyperbolic x? Basically, if we define tan hyperbolic function from all real number to -1 to 1, in that case, we can get a onto function. Onto, in that case, tan hyperbolic x is onto. But if we define the function tan hyperbolic function from R to other than -1 to 1, then in that case, tan hyperbolic function is not 1 because here the domain, here the codomain and the range set is different. So here, in that case, tan hyperbolic x is not surjective. But if we define tan hyperbolic function from R to -1 to 1, in that case, the range set equal to codomain. So in that case, tan hyperbolic x is surjective. Okay. Here is the summary. Tan hyperbolic x, this is the formula, and the domain is R, range is upon interval -1 to 1, and this is a odd function. And limit x tends to infinity, tan hyperbolic x is equal to 1, and similarly limit x tends to minus infinity, tan hyperbolic x is equal to -1, and derivative of tan hyperbolic x is equal to sec square x, sec hyperbolic x, and this is an increasing function. This is 1 function, and on the interval -1 to 1. Okay, that is all about today's class. See you soon in the next lecture.